Section of Homework 10, we will talk about compound interest. Compound interest is where you get interest on your interest. In the last video, we saw the example with the increase in tuition for 2 years, and the 5% increase was on top of the 5%. That's compound. So we have a different formula for it, which is a little more complicated. The amount we end up with is equal to the principal, or the present amount of money we have, times 1 plus R divided by N. R is the annual percentage rate as a decimal. N is the number of compoundings per year. Sometimes this NT is going to be very large, so you need to have a calculator that has an exponent key on it. You don't need to have a graphing calculator like I have, but if you have a calculator similar, or if you have this one, you can use this one. It needs to have this little key. This is called the caret key. That's the exponent key, or an x to the y, or a y to the x key. So it needs to have an exponent key. One of these keys these are the typical exponent keys on calculators. It's possible that you would have a different one, but if you want to know for sure that it's the right one, try doing 2, hit the key, then 3, and you should get 8. So you can test it out if you're not sure if that is the key. Do the 2, the key, the 3, and see if indeed you get 8. Okay. In this formula, A is the amount at the end of T years. P is the principal, or the present amount. R is the annual percentage rate, sometimes called APR, and it's got to be a decimal. So convert it to a decimal. N is the number of compoundings per year. I did mention up here that T is the number of years, but perhaps I should stick it in the list so we know that T is years. Okay. The number of compoundings per year, if we compound annually, there's 1 compounding per year. If we compound semi-annually, there are 2 compoundings per year. If we compound quarterly, there are 4. If we compound monthly, there are 12. If we compound weekly, there are 52. Daily, there are 365. I've never known of a case where leap day was counted, but sometimes 360 is used. Yes, for the calculations, that could make a difference in the amount of money. And you can actually compound more often than that. In fact, all the way to every instant, but that's beyond the scope of this class. We're just going to go this far. Okay, so these are the formulas we're going to use. And if we want to know the actual interest earned, the interest earned is going to be the amount you end up with minus the amount you started with. That's how you figure out how much interest you either earned or paid. Okay, so let's look at a couple of examples of this. Okay, the first example, I'm going to say $1,800, $1,800 is invested in an account compounding quarterly at an APR, annual percentage rate, of 5% for 3 years. How much money in the account at the end of the 3 years? That'll be part A, and part B, how much interest earned. Form is working a little differently than the previous formula, so it's easier to figure out the amount first and then the interest. Okay, let's look at the formula and put in all the numbers. You'll notice in your book, textbook, and other things, you don't usually see that NT written in the parentheses. Order of operations would tell us those parentheses, that the NT is inside of the exponent, so we would do it first. I like to put the parentheses there to ensure that myself and my students realize that that has to be done first. And we're going to put the whole thing in at once, so we're going to get the right answer more accurately, but we've got to put those parentheses in. If you do these problems in parts, you may be off a little bit. So it's best to put the entire thing into your calculator in one step so that you don't lose or gain any pennies or dimes. Okay, or if the numbers are big enough, they could be dollars. Okay, so the principal is $1,800. The rate is 0.05, because remember I have to change it to a decimal, so move the decimal 2 to the left. It's going to be compounding quarterly. How many quarters are there in a year? 4 per year. So I'm going to divide by 4. That's because you're not going to get 5% interest every quarter. You're going to get 1/4 of the percentage interest the first quarter, and then some more the second, more the third, and more the fourth. So finally, by the end, you will have had the whole 5%. There are 4 per year, and how many years am I leaving it is 3. So notice that's telling me that I have 12 quarters in 3 years. So 12 is the total number of quarters I'm going to leave it. Now sometimes you can do the division here and you will just be fine because you'll get an exact number. Other times you will not. So if I do 0.05 divided by 4, I get an exact number, 0.0125. If I had had 3 there, though, I would have gotten 0.016666, and really, it doesn't end here at 7, it repeats that 6 forever. That's what can mess up your answer, if you do that first. In this one, it's not going to mess up our answer, but I'm still going to put the entire thing in. So I'm going to put 1,800 times, and some calculators require you write the times. With some, you can just write the parenthesis. 1 plus 0.05. I'm hitting the divided by key, and on my calculator that looks like a slash. Divided by 4. And then the exponent key minus the caret. And 12. So I do usually go ahead and multiply that exponent out. Now you could multiply this by hand. 1.05 divided by 4. 12 times. Or you could do the 0.05 divided by 4 and have those decimals and multiply it out 12 times. You don't want to do that. Okay, we want to round to the nearest penny. So that's going to be $2,089.36. $2,089.36. Double check. I have a very good memory. Yeah, that number would have been 0.0125. So I'm doing 1 plus that, 1.0125 times 1.0125 times 1.0125 12 times. When I finally get that answer, I'm multiplying it by 1,800. So if you did that by hand, you've got to be careful that you don't lose the accuracy of these decimal points. Your answer could come out different. Okay, so if I rounded to the nearest penny, that's how much money I would have. If I wanted, I could round to the nearest dollar, round to whatever's asked for. Okay, so the answer to A is $2,089.36. Like I said, you could round to the nearest dollar, $2,089. You could round to the nearest $100, and you would have what? $2,100. So you can do some rounding. It just depends on what information you're looking for. In my math lab, make sure you read the question. It can ask you to round to the penny, the dollar, or the $100. How much interest was earned? Well, I started out with $1,800, so I need to subtract $2,089.36 minus $1,800. Make it $289.36. So the amount of interest I earned over the 3 years was $289.36. Okay. Let's perhaps do a second example. And then I want to do an example of the present value. So let's suppose, for now, $2,400 is invested for 2 years into an account paying 6% APR, compounding daily. Okay, how much money at the end of the 2 years? And let's also ask how much interest earned. Okay, so $2,400. Okay, A is P times 1 plus R over N to the NT. The P is how much I start out with, $2,400. The R, remember I have to change it to a decimal, so that's 6%, changing to 0.06. Compounding daily. I'm going to put a note in here. Let's use 360 days. If you're not told that, use 365. If you're told that, use 360. So I'll use 360 times how many years? 2 years. So 1 plus 0.06 divided by 360 to the 720. 0.06 divided by 360. That's a tiny little number. This E right here means it's very tiny. It means times 10 to the negative 4. In other words, it means move the decimal place back 4. So 1, 2, 3, 4. So that's a tiny little number. You would have trouble doing that by hand. Multiplying that out by itself 720 times. So you definitely need a calculator that has on it an exponent key. So I'm going to do 2,400 times. Some of the calculators require that you hit the times, others don't. 1 plus 0.06 divided by 360. Close that parentheses and then use your exponent key, whatever yours looks like. Do 720. $2,705.97. 27.05 and 97 cents. 97 because 5 is 5 or bigger, so this number goes up by 1. So what did I get? I got $2,705.97. The end of the 2 years, how much did I earn in interest? 300, $5.97. Again, you want to be careful that you follow the directions. Does it tell you to round to the nearest penny, the nearest dollar, or the nearest $100? This said to the nearest dollar, that would be $2,706. So I would have earned $306 in interest. Said to the nearest 100, it'd be 2,700. So in that case, I would have earned $300. So that's for a good estimate. Okay, let's go the other way now. Let's suppose I know that I would like to have $10,000 5 years from now. Maybe I want to buy a house or a car or for my kids or grandkids or something, college. So I want to have 10,000 5 years from now. So my question is, how much do I need to invest now? In other words, we call this the present, to have $10,000 5 years from now. If my investment account pays 8% APR, compounding monthly. Typically, accounts are going to pay more the longer you're willing to leave your money there, or the more amount you put in. So if you put a lot of money in, even if you don't leave it long, that's a short-term loan they can make and make money off of that. So they're going to pay you some of that. If you're going to leave it for a long time, they know they can use it for a long time. So typically, either the more money you put in or the longer you leave it, the higher the interest rate you can get. And the more compounding you can have, the better money you're going to get. But the interest rate is really more important than the amount of compounding. Although if you get them close, the compounding definitely makes a difference. Okay, so what do we have here in our formula? It's the same formula we have here. Okay, except it's the P that I'm going to solve for, because I want to end up with $10,000. I have P, I don't know how much I need, that's what I'm trying to find out. My R is 0.08, so I've got to change it to a decimal. I'm compounding monthly. How many months are there in a year? 12. And I'm going to leave it for 5 years. So 10,000 equals 1 plus 0.08 divided by 12 to the 60. Now I can actually make a new formula here. I can solve for P by just dividing both sides by 1 plus R over N to the NT. And we call that the present value formula. Because how much money do I have to have in the present? Or I can work this out to this point, figure out what this is. 1, I need the parenthesis, even though the P is unknown, I still need the parenthesis here. 1 plus 0.08 divided by 12, because I want the entire thing in the parenthesis raised to the 60. Now at this point, I'm going to be safe rounding a bit. It's the compounding with those number of exponents that messes up your decimal places. So here, I'm going to only have one step left after that, and that's to divide. So I'm going to say 10,000 equals 1.4898. 4898 P. That's not exactly equal. I'm rounding. But since I'm rounding to 4 decimal places, I should be pretty safe here. I've got only 4 zeros here. Let's see how accurate I am. So 10,000 divided by 1.4898 is $6,712. Approximately. Be safe. Just go ahead and put in $6,713 and you will have some extra. So that's how much they could put in now. I'm going to round to the nearest dollar. And like I said, I could put in a little more. Get that. That looks like that's accurate to at least that 10th place, so when I round I will be correct. If I tried that and it wasn't quite right, then I could try the other number, 6713. But let's see how close it is. 10, 1, 2, 3, divided by 1 plus 0.08 divided by 12 raised to the 60. Yeah, it looks like by rounding 4 decimal places, I was off how much? 20 cents. 21 cents. So I was off a little bit by rounding only to 4 decimal places. So don't think that's a good idea to try and get away with 1 decimal place. Let me do those. Okay, and the next one, we're going to look at loans where you do installment payments. Usually if you borrow money, you don't just hold on to it all and pay it all back at the end. You pay back some every month. So the next one we're going to look at monthly payment plans, monthly installment buying.